This problem, we have to find the number of 3-digit numbers which leaves remainder 6 when divided by 19 and remainder 8 when divided by 13. So let the 3-digit number be some n. Let the 3-digit number be some n. In order to solve this problem, we'll use division algorithm. Division algorithm is nothing but dividend is equals to quotient into divisor plus remainder. Now let us look into the first case. Dividend is nothing but the number n. When you are dividing that number n by 19, the remainder is 6. So the divisor is nothing but 19 and the remainder is 6. We have no information about quotient, so let the quotient be some p and consider this as equation 1. Now in the second case, same number n is divided by 13 and we have obtained the remainder as 8, whereas the quotient is unknown. Again, let it be some q. Let this be some equation 2. Now from equation 1 and 2, we can say that the number is same, so we can equate the right hand side, which will be nothing but 19p plus 6 is equals to 13q plus 8. In order to solve the problem, convert everything into either p or q, preferably q. If I write this as 19p is equals to 13q plus 2, the value of q will be 19p minus 2 by 13. Now we'll go by trial and error method to find the values of p and q. And one more important thing, q is a quotient, so definitely it should be an integer. So this value must be an integer, that two positive integers. So if it is an integer, you can consider 0 also. If it is an integer, you have to select the values of p such that this total expression is integer. So there are few values of p, which are 9, 22, 35, 48, 61 and so on. Whereas q is 13, 32, 51, 70, 80, 9 and so on. Now if I substitute 9, 22, 35 and 48 in equation 1, you will get the value of n as a 3-digit number. But if I substitute this 61, it will be a 4-digit number, which is not 3-digit number, which is not required. So for only 4 values of p, we'll obtain a 3-digit number. So the required number of numbers are 4, which is option C. Let's look into the problem. The LCM and HCF of two numbers are 150 and 9 respectively. If one of the numbers is 30, then find the other number. It is given that HCF of two numbers is 9 and their LCM is 150. And one of the numbers, let us say some A as 30. Let us say the other number as B. We have to find that other number. So HCF is given as 9. LCM is given as 150. A, that is one of the numbers, is given as 30, and B, let it be some other number we have to find. Now, there is a basic property in LCM and HCF. Whenever we are talking about this LCM and HCF, LCM will be always a multiple of HCF. LCM must be always a multiple of HCF, but 150 is not a multiple of 9. That means whatever the data which is given is wrong. If the data is given wrong, then we cannot answer this question. So in this, we cannot find this B. That means B does not exist. Option D is the answer. Or if you want it in more simplified way, the numbers will be always multiples of HCF. Numbers must be always multiples of HCF. But 30 is not a multiple of 9. So clearly we can say that the given data is wrong. Hence the answer is does not exist. Find the sum of the series 3 plus 6 by 2 plus 9 by 4 plus 12 by 8 and so on. The given series is 3 plus 6 by 2 plus 9 by 4 plus 12 by 8 and so on up to infinity. Let us take this series as some S. Now look into the series S, which is not in arithmetic progression, which is not in geometric progression, which is not in harmonic progression. So whenever these type of series are there, by certain additions or subtraction, we can convert them into either arithmetic progression or geometric progression. Now, so in order to convert them into geometric progression, what I do is I'll divide this S by 2. So S by 2 will be 3 by 2 plus 6 by 4 plus 9 by 8 plus 12 by 16 plus so on up to infinity. Then I'll subtract this s by 2 from s, which will be 3 plus 6 by 2 plus 9 by 4 plus 12 by 8, so on up to infinity, minus 3 by 2 plus 6 by 4 plus 9 by 8 plus 12 by 16, so on up to infinity. I'll keep this 3 as it is, keep that 3, then 6 by 2 minus 3 by 2, so that the subtraction will be easy, plus 9 by 4 minus 6 by 4 plus 12 by 8 minus 9 by 8 plus so on up to infinity. This will give us 3 plus 3 by 2 plus 3 by 4 plus 3 by 8 plus so on up to infinity. Clearly, which is a geometric progression up to infinity. Whereas A is 3, R is 3 by 2 by 3, which is 1 by 2. So the sum to infinity is given by the formula A by 1 minus R, which is 3 by 1 minus half. Whereas RHS is nothing but S minus S by 2 is S by 2. That is equals to 3 by 1 by 2, which implies S by 2 is equals to 6. That implies S is equals to 12. So the option is A. If the ratio of the percentages of A and B is 7:8, then which of the following cannot be the ratio of their ages 3 years ago? Now, ratio of the percentages is given as 7:8. That is nothing but 7 by 8. Now he is asking which of the options cannot be the ratio of their ages 3 years ago. First of all, let us see a property in ratio and proportion. If A by B is some ratio, if you are subtracting any constant C from the numerator and denominator, that is from the both ratios, both the values, then the resultant ratio, which is A minus C by B minus C, will be always less than A by B. Always less than A by B. Now let us consider the percentages, ratio of percentages. What is the ratio of percentages? 7 by 8. If we simplify, if you convert it into decimals, it will be 0.875. Now, the values in the options must be less than this 0.875. Then there will be the ratio of the ages ago 3 years. Could be. Now let us see first one. 2 by 3. 2 by 3 is nothing but 0.66, which is less than 0.875. So this can be the ratio. Next, 4 by 5. 4 by 5 is nothing but 0.8, which is less than 0.875. So this can be the ratio 3 years ago. 6 by 7, which is nothing but 85.68, which is again less than 0.875, which can be the possible value of the ratio 3 years ago. Now 8 by 9. 8 by 9 is nothing but 88.88, which is not less than 0.875. So this cannot be the ratio 3 years ago. So the answer is D.